So our next speaker, the last one for this session, is Arvind Kamath from Ensurge, Ensurge, and I don't need to read the title; it's already there. So, Arvind, the stage is yours.
Hi, I appreciate the interest in the talk. So I'm going to be talking about the manufacturing scale-up of solid-state lithium microbatteries. Very different from the printed batteries you earlier heard about. But what we're trying to do here is build MLCC-like SMT-compatible, very high energy density microbatteries that can be used in new classes of wearables and hearables. So let's start really with the market and what problem we are trying to solve. What's the underserved area here? So essentially, Ensurge in the past few years has been working on applying its extensive capabilities and IP, which was earlier applied to actually roll-to-roll based electronics and repurposed into making this class of solid-state microbatteries. So we build our batteries on very thin stainless steel substrates, an area we have a long history in building electronics on stainless steel. So we realized that really the new emerging markets, which have actually already emerged and are quite strong, are really in hearables, wearables, sensors, and sports and fitness wearables. So if you look at the picture in the middle, you will see the batteries. There are three, which are driving LEDs there as an example. So you will see these are SMT-compatible batteries. So all of these applications are very area limited and very area limited, form factor limited, and also in terms of volume. So what we have to do here is pack as much energy as we can into the smallest possible volume to be comparatively way better than our competitors, which are not printed batteries. These are rechargeable cells, but going head-to-head against lithium-ion coin cells and lithium polymer batteries. So where can we be much superior? So the three areas, really the three battery parameters which are valued the most are the fast charging, very high energy density, and overall the form factor, which is to make them very thin, especially in height-limited applications, area-limited applications. Unlike coin cells, which come in fixed sizes, make the shape and height customizable, and quite importantly, make these compatible with a standard SMT process so that they can be picked and placed and reflowed. I'll talk in this talk, I'll go over the manufacturing aspects and the scale-up challenges that we have faced over the last years and solved in order to take these cells from lab to fab and into the marketplace. We do all of our manufacturing and packaging internally in-house in our fab in California. We have quite an extensive roll-to-roll and sheet line there, which was originally built for transistors on steel. So we have a quite remarkable tool set. We use only a small subset of this in making the batteries. So let's look at this graph and see where we want to win. So in the left graph, you'll see the Ensurge batteries, and where we want to be, where we are, is really building in the volumetric energy density has to be very high. So if you look at lithium-ion coin cells, these tend to be in the 300. The best lithium-ion coin cells, rechargeable, tend to be in the 200 to 400 watt-hours a liter volumetric energy density. we